What's up, guys? Today we're going to be solving 114 flattened binary tree to a linked list. This is a pretty famous question that's been asked by many big companies such as Google, Amazon, and Facebook. So it's quite important to go ahead and understand this. First of all, the whole point of the question is to go ahead and produce a post-order traversal linked list of any given binary tree. So very quickly, I'll show you guys what post-order traversal means. Really, it's as simple as just drawing the outline like this. And then every single time we hit the left side of a node, we go ahead and put it into the list. So first, when traveling in this manner, we hit the 1 first, then 2, then 3, and then you see we end up hitting the 4 right here. And then we go back and back like this, but we've already hit the 1. So now we hit the 5 on the left side. And going down even further, we finally hit the 6. So the whole point is to output a linked list in this fashion for any given binary tree. All right, so how would we go ahead and go about this? First of all, is choosing what kind of algorithm we'll go ahead and use. When looking at this, you should probably think about DFS, because when you do DFS, you kind of travel in this manner and it's easier to think about it than BFS. The second thing to think about is kind of the format of how everything looks like. If you go ahead and notice, it seems like this entire tree, right, is going to be in between here. Then this entire tree is going to be in between here. Clearly, we have a recurring pattern, and using recursion is a good idea. It's a solution for this, but I'm going to opt out for the iterative solution because I find it just a bit easier, more intuitive for me than to go ahead and think about this recursively. So the way I'm going to go ahead about this is just traveling this in normal DFS fashion, but every single iteration, I will go ahead and take the previous node's right pointer and point it to the next node. So let's go ahead and apply our solution to this problem so that you can see what I'm trying to say. First of all, we will go ahead and have a stack, right? When you do DFS, you use a stack, right? So the first node we're going to add is 1. And then at this point, we go ahead and pop the 1. When you pop the 1, you usually add the right and left side in that same order. And one thing to note is that our previous node is 1. We're going to have sort of a variable to track our previous node. Let's put it right here. Great, so let's go ahead and add the right and left side. Great, so now we're at the second iteration of our solution, and we got to go ahead and pop the top node in our stack, which is the 2. So when we pop this, first we got to go ahead and say, well, our previous node was 1. I want to take its right side, make it point to my current node that I'm popping, right? My current node was 2. So I'm going to take the right side and make it point right here. And our left side, I will just make it point to null. We're going to have to go ahead and do this for every single node, so just keep that in mind. Now, since we're popping 2, we got to go ahead and add its right and left side like normal. Great, so now we're back at the third iteration of our problem, and we got to go ahead and pop 3. But like I said before, we got to go ahead and take our previous node, which at this point should be 2, and we got to go ahead and make it point to the current node on its right side. So we take 2, we make it point to 3 on its right side, and the left side, it points to null. All right, so I'm going to go ahead and speed forward the solution because it's going to get a bit long, but I will literally keep going through this process over and over again until I reach the last node, 6, and stop. And at that point, we'll have exactly this right here. It looks a bit clumsy for now, but if you were to go ahead and kind of stretch everything out and straighten it, it would look exactly like. All right, so let's go ahead and look at the solution. First of all, I went ahead and already initialized all the stuff that we need. So I imported deck to be able to have a stack. I set up our base case where if we have nothing, then we return nothing. Initialized our stack, and I initialized our previous variable, which will be none for now, because we got to go ahead and add the 1 first but it doesn't have any previous node, so there's no point adding one for now. So first things first is we always got to go ahead and pop our first node. So we do, and that's it to pop our first node. Second thing we got to go ahead and do is check if we have a previous node, and if we do, then we do the trick that I discussed and showed before by taking the previous right side and adding it to the new current node that we have, and taking its left pointer and pointing it to null. All right, so the next thing we got to go ahead and do is to go ahead and traverse this in post order DFS fashion. So that when we go ahead and do this trick right here, it actually reorganizes everything in the manner that you want it. When we go ahead and do DFS and we want to go ahead and travel it in post order fashion, we always got to go ahead and add the right side first and then the left side. So we first got to go ahead and check if there is a right side. And if there is, we go ahead and append it to our stack. For the left side, it's going to be exactly the same thing. So you can go ahead and just copy this and just change it to the left side variable. And the final thing is that you got to go ahead and actually update your previous node to reflect what is actually the previous node in the next iteration. So we set previous to basically the current node that we have now, so that when you loop back, previous is actually the old current. Now, the important thing to also note about this is a in-place solution, so it's actually very good on space complexity. And if you're interviewing at these top companies, they're probably going to go ahead and add a constraint where you have to go ahead and solve this in O of 1 complexity. Yeah, so you gotta do stack.pop, not node.pop. And there we go. We have great runtime complexity, amazing space complexity as well. Guys, if this helped you in any way, shape, or form, please leave a like and subscribe, and I'll see you in the next one.